Hello and welcome to another tutorial. I'm Mr. Muhammed and this is Revise for Checkpoint book. Unit 19 is about bearings and drawings, maps and scales. So let's get started. As we go along, I'm going to give you some hints and tips to help you understand the scales more. Now, let's start with question 1. A toy soldier is made to a scale of 1 to 12. The toy is 14 centimeters tall. How tall would the corresponding real soldier be? So in this question, we have a ratio and we have the length of the model. Then we need to find the height of the real soldier. So let's write the ratio. It's 1 to 12. And this is in the ratio. And in real life, so let's consider the one as the toy because always the toy is shorter than the real one. 14 to, we don't know the height of the soldier in real life. Then think how 1 becomes 14 if we multiply it by 14. Then to get this number, we have to multiply 12 by 14. 12 times 14 is equal to 168. So the height of the soldier in real life is 168 centimeters. As meters, we can also write as 1.68 meters. So this is the height of the real soldier. Question 2. Two towns are 120 kilometers apart. They are shown on a map with a scale of 1 to 5 millions. How far apart are the towns on the map? So when you see a ratio like this, 1 to 5 million, so it means 1 centimeter on the map represents 5 million centimeters in real life. So to make this more understandable, 5 million centimeters in real life, 5 million 5 million centimeters. If we divide this by 100, it will be meters. 5 million centimeters is equal to 50,000 meters. And if we divide this by 1,000, that gives kilometers. So it is 50,000 meters divide by 1,000 to get kilometers. So it's equal to 50 kilometers. It means 1 centimeter on the map is 50 kilometers. The scale, now it's understandable. 1 centimeter on the map represents 50 kilometers in real life. This ratio is easier to understand. Now the two towns are 120 kilometers away from each other. How many 50s are in 120 kilometers? Let's divide 120 kilometers, and because the 120 is in kilometers, that's why we need kilometers here, because we cannot divide kilometer by centimeter. Now 120 divided by 50, they both kilometer, they have the same unit, so it's a reasonable division. It's equal to 2.4. So it means the two towns on the map are 2.4 centimeters away from each other. So the answer is 2.4 centimeters. Or as millimeters, they are 24 millimeters away from each other. For question 2, how did we get this? The ratio, there is no unit on the ratio, so straight away you think about centimeter. This is the easiest. 1 to 5 million means 1 centimeter on the map is 5 million centimeters in real life. Then you can get that 1 centimeter is 50 kilometers in real life, and with division you can get how far they are on the map. Question 3. A map is made to a scale of 2 centimeter represents 1 kilometer. Okay, write the scale as a ratio in the form of 1 to n. Write the scale as a ratio in the form of 1 to n means we have to make something like this. Now, to make something like this, we need to have 1 centimeter. This is 2 centimeter, represents 1 kilometer. Because the units are not the same, we cannot make something like this. Let's make the units the same. 1 kilometer, if we multiply it by 1,000, it will be 1,000 meters. And 1,000 meter, if we multiply it by 100, it will be centimeters. So 2 centimeters on the map represent 1,000 meter. If we want to make it centimeter, we need to multiply it by 100. Then 1,000 times 100, it will be 100,000 centimeters. Now we have the same unit. We can write it in the form of 1 to n. It means on the map 2 centimeter represents 100 centimeters in real life. Then what about 1 to n means we need to make the side 1. How 2 becomes 1 if we divide it by 2? Then it's 1 centimeter 2. It's divided by 2. So we must divide the other side by 2. 100 centimeter divided by 2, it will be 50,000. 100,000 will be 50,000 centimeters. So the scale for question 3 is 1 to 50,000 without units. Question 4. A model of a world's tallest horse, Big J, has been made on a scale of 1 to 20. The scale is 1 to 20. It means 1 centimeter of the model represents 20 centimeters of the real horse. Now, let's write it as ratio and get the height of the model. Okay, the ratio is 1 to 20. And the real horse is 2.1 meters. This is the real horse. Okay, then how can we get benefit from this ratio? To get benefit from this ratio, because there is no unit, I told you straight away consider centimeters. 1 centimeter of the model represents 20 centimeters of the real horse. Then this height of the real horse is given in meters. Convert this to centimeters. 2.1, if we multiply it by 100, it will be centimeters. So it's 210 centimeters. Then how many 20s are there in 210? 210 divided by 20 is equal to 10.5. So it means the model is 10.5 centimeters high, while the real one is 210 centimeters. Question 4 is 10.5. Question 5, again it's about a map and the scale is 1 to 5,000. There is no unit. It means 1 centimeter represents 5,000 centimeters in a real life. Two features are 5 centimeters apart on the map. How far apart are they in reality? So 1 centimeter on the map represents 5,000 centimeters in real life. We're about 5 centimeters. So 5 centimeters on the map, it's multiplied by 5. 5 times 5 is 25,000. 1 centimeter is 5,000 centimeters in real life. So 5 centimeter will be 25,000 centimeters in real life. To write this in meters, because in real life, meters are more reliable than centimeters, then 25 centimeters, if we remove 2 zeros, it will be meters. It means if we divide it by 100. Remove 2 zeros, so the two features are 250 meters away from each other in real life. Now, bearings. Bearing is an angle and it is always clockwise. This is a good working example here. And now, a hiker plans a long walk. It consists of 6 stages, A, B, C, D, E, and F. Shown on the map, measure the bearing of each stage using a protractor. Then to find bearing, we need protractor as the question wants. And remember, bearing is always clockwise. So the bearing for this angle, the bearing of section A is this angle, the bearing of section B is this angle. For section C, it's this angle. And here for D, it's this angle, this reflex angle. For part E, the angle is like this. And for part F, the angle is like this. So for these angles, it's okay straight away measured with protractor. But for such angles, when the angle is more than 180 degree, it's more than a straight line, we have to measure the other side. We have to measure this side anti-clockwise. And whenever you measure an angle anti-clockwise, you have to subtract the result of anti-clockwise from 360. Then you'll be able to get the bearing. Okay, let's start. So I have a protractor here. Now let's start. How can we use it? Protractor must be like this. The protractor, the north, and I draw the north for each section. Then we will be able to find the bearing. Now, stage A, the bearing, it's obvious that it is 74 degrees. So this bearing is 74 degrees, the bearing of section A or stage A. The bearing of stage B, look, the center of the protractor is on the center and this side is straight with the north. Look, this 0 is straight with the north of the angle. Now I'm looking to the other side. Here is 20, 2 steps less than 20. So this one is 118, this bearing, 118 degrees. This bearing here, since it's more than 180 degrees, I'm not going to measure it like this. I'm going to measure the way around. I'm going to measure it anti-clockwise. Then the result of anti-clockwise must be subtracted from 360 to get this bearing, to get this side. Because this side, which is anti-clockwise, with the bearing together, they complete 360. This angle is 161 degrees. Now 360 minus 161 is equal to 199 degree. Then this bearing, this angle is 199 degrees. This reflex angle, again, because the angle is more than 180, I'm going to measure it anti-clockwise, then subtract the result from 360. Anti-clockwise, this angle it's 112 degrees. So the anti-clockwise is 112 degrees. How can we find the bearing? Then we will say 360 minus 112. That gives 248 degrees. This angle is 248 degrees. Now this angle, stage D done. Now stage E. Again, the angle is reflex. I'm going to measure this angle inside, then subtract it from 360. This angle is halfway between 60 and 70, so it means it's 65 degrees. This is 65. How can we get the bearing, which is the clockwise angle? 360 minus 65 is equal to 295 degrees. So this is 295 degrees. And finally, this angle is more than 180. So we have to measure this tiny little angle here, this angle, and then subtract it from 360. This angle is 8 degrees. Then 360 minus 8 is equal to 352 degrees. Now we got all the bearings. So in bearing, it's okay if you get one more degree. So it's plus minus 1 means if it's 118, if you get 117 when you are measuring, not calculating. For calculating, you must get the exact bearings. But for measuring, when you are using protractor, because not all the protractors are exactly the same, that's why plus minus 1 degree is acceptable. For example, I get this angle 248, you might get it 249, it's okay. Or this angle I got at 295, it's okay if you get it 294, acceptable. Or this angle I got at 199, it's okay if you get 198, because it's measuring, it's not calculating. Then I hope you find it easy. Comment below whatever question you have. Thank you for watching.